Hello friends, and today we'll be doing an experiment that you probably will not understand. It's so simple that most people will not understand it. It's a bit like when an elephant's able to hear a noise that humans cannot hear because it's such a low frequency noise that it's beyond the range of human hearing. So too, this experiment is so simple that most humans I think will not get it. But we have to do it anyway because it shows exactly what the universe is composed of. And we'll actually be doing two experiments. One will be the simplest experiment in the entire universe. And the second experiment will be the second most simplest experiment in the entire universe. Okay, so here's the subject matter. It's just a marble. It's a steel marble. It's just made of iron and chrome. It's stainless steel, ball bearing, and we put it here. And in the universe, it just is there. It's just sitting there. It just exists. Okay, ready for the experiment? Here we go. There, did you catch it? There it is, existing among matter. All the matter of the entire universe is all around it. So, simply by just being there, simply by this marble just being there among all of space and time, it shows exactly what it is. And simply by being there, it shows that it is space and time itself. And the reason for this is because it is just being there. And by just being there, it's showing exactly what it is. Because if it wasn't there, it would be found to be at no place, and yet there it is, in a place. So it's holding place. And it's holding now. It's holding time. So the fact that it's here, the fact that it's now, shows exactly what it is, that it is a chunk of space and time. So Einstein figured that matter was caught in a space-time web. But if Einstein had understood that matter was that space-time web, then he would have been able to explain all forces, all properties to matter, if he'd only understood that space and time and matter were one thing. But Einstein is to be praised in that he did understand that both time and space were one thing, but he didn't get the one-third left of that understanding, is that time, space, and matter were one thing. So there it is, there you have it. The simplest experiment in the entire universe is that matter just is. It's just there, and because it's there, we can see that it does everything it does. Well, you'll actually need help to see all the things that it, why it does what it does. But what's interesting is that by its existence, through simply existing, it does everything that it does. And this is a bit like a parable because God also just is. And by being God, he does everything he does. The Bible tells us that God is love. And because God is love, he does everything that he does. He is the actor of love. Love is what God does. And through just being love, God does everything he does. So in the same way, he's made matter to do just that one thing. And in the Bible, I remember it also says about God, I am. And I am is simply a state of being. And so too, this marble here is simply in a state of being, and because it's there, simply because it's there, it does everything it does. And what does this marble do? Well, it's just there. It's just there to be pushed around. It's just there among all the other marbles to be pushed around. And that's the thing, is that it's not alone, this marble here. It is among all the other marbles, just there. And so you have a lot of marbles just being there. And, you know, this marble pushes this marble, and then actions happen. And very, very many things happen because it's just there. You see, the universe is not empty. It's full of matter. It's not just one marble that exists out there. It's all the marbles that exist everywhere that causes these things to happen. Which leads us to experiment number 2, the second most simple experiment in the entire universe, which we're about to do. We're about to prove that all the stuff that's out there is just dust, and that dust is just physical existence, and physical existence is both space and time itself, through experiment number 2. And experiment number 2 is also very, very simple. It's going to be very, very simple. So here we have a tape measure, a regular tape measure. And what we're going to do with this matter is we are going to displace it in a line. Instead of just being there, just sitting there, we're going to displace it in a linear fashion, displace matter with it in a linear fashion, and it is going to go through a resistance, and that resistance is going to slow its motion, but by me pushing it along, it is going to take distance, and it's going to take time to travel. So when this thing travels, this is a big experiment here, when this thing travels, it's going to take both time and space, but it's not going to take fully existing time, it's going to take linear time. And it's not going to take fully existing space, it's going to take linear space, which is distance. So here we go. The second most simple experiment in the entire universe. Here we go. Okay, so the marble, when I pushed it with that much force and with that much resistance, stopping it, it traveled 5 inches, and it did so in 2 seconds. So we see that by me pushing the marble with that much force, it took both time and space in a linear direction. So it proved what it was simply by being there to be pushed. But also, it proved what it was because it traveled in a linear way. So when we displace all this ocean of matter around it with this, and this resistance that runs into because of the ocean of matter and because of what it's on, and everything else around it, it took both time and space to do it. And what else takes time and space besides a chunk of time and space? So, here we go. Just to clarify, 1001, 1002. Okay, with that much force and with that much time, we used up 2 seconds and went 5 inches. Not only can we show that it's displacing matter linearly, but we can also show that it's displacing time linearly. Instead of using a linear measuring tool, we can also use a different linear measuring tool, a clock or stopwatch. So with this linear measuring tool, we can also show the time it takes, the linear time it takes, that this fully existing piece of time is. So there we've proven that this is a chunk of space and time. But it took force to push the marble along, and that force that I was applying to it was pushing on it with my finger like this. What I was doing when I was pushing it with the finger is that I was applying push behind it, and that push was simply push from my finger. So it could just be another marble pushing on it like this. As long as you have more stuff behind it pushing and stuff in front of it not pushing as much, you'll have the marble go forward. The resistance that marble ends up crashing into is just other marbles. So say that this marble here wants to go forward, but it can't because there's other marbles blocking it. And this is the push behind it of other marbles rushing in. So you got other marbles rushing in here, and other marbles stopping it. But because there's more rushing behind it, there's more stuff, there's more push behind it, that it will be able to get through the other marbles. And that is simply what all motion is in the entire universe. And that's why it takes time for any marble to move. In fact, if you take away all of the other marbles on the one side and put all the other marbles on the other side, pushing it along, then this marble here, and if there's a hole here and no hole here, then this marble will take absolutely no time to fall into this hole, because there's no time here. Not only if there's a hole here and there's push here, will it take no time for this marble to go from here to here and to fill this hole, but also it will take no space as well, because this is a chunk of space. So exactly how much time it will take for this marble to fill a hole that's not there is absolutely no time, because again, this is time. And it will take no space, because again, this is space. In fact, you cannot have space nor time if you don't have marble, aka if you do not have dust, because everything's made of dust. That is, everything is made of chunks of space and time, which is what all marbles are. And that's why acceleration happens. Acceleration happens because there's push behind the marble and there's less stuff in front of the marble. Because acceleration is not instantaneous is because there's stuff in front of the marble that's blocking the marble from instantly being there. So acceleration has to do, that is every force, every push that exists in the entire universe has to do with simply there's more stuff behind it and less stuff in front of it. And there's never a time when there's an actual complete and total whole, because if there's an actual complete and total whole, there's actually not a whole there. It's just finer matter there that gets displaced, and finer matter with more holes, or whatever the case may be as to the arrangement of the matter, which allows for more holes to be on this side rather than this side, which causes that acceleration. That's what you see when ever something is accelerating. Or now it brings us to the second point, the deceleration. And in the deceleration, you're just running into more matter. So here, say this ball was accelerated towards the matter, and it starts running into more matter. When it starts running into more matter, it slows down. Why? Because it's running into more space and more time, which is why it's slowing down. And so we see again, in everything it does, in every motion that this does, it shows exactly what it is. It's just a chunk of space-time existing among all the space-time. So whether it's just sitting there, proving what it is simply by sitting there, or whether it's moving into stuff or being pushed by that stuff, no matter what it does, whether it's just sitting there or accelerating or decelerating, or whether it's just going at a constant rate because it's running into as much stuff as it's being pushed by. And so it remains at a constant speed. Whether it's accelerating, decelerating, or remaining at a constant speed, it remains. And as long as it remains, it shows exactly what it is. A chunk of space and a chunk of time. So that's it. The simplest experiment in the entire universe shows that this is simply a chunk of space and time and matter, all one thing. It shows it by the simplest experiment in the universe, it just simply being there. And the second most simple experiment in the universe, it's taking action by simply being there, to be pushed and to be stopped, and simply just to be pushed around by other stuff. Because whenever it moves in a line, it takes both space and time.